This is the lesson for Thursday, January 31st. And in this section, in this lesson, we're gonna cover section 4.5, part 2. So we're going to continue to use two-factor polynomials. And in this lesson, we're going to be learning, the grouping method. So the grouping method we use when we have a polynomial of 4 terms. So when you think about grouping, you're going to think about a polynomial of 4 terms, all right? Now, the first thing we learned when it comes to factoring was the GCF. Now, always, you will always check to see if there is a GCF before you do anything. So I'm going to look here. I have the number 6, 21, 4, and 14. Between 6 and 21, you have a factor of 3 that you can factor both out, but not between 4 and 14. All right. So when I look for the problem as a whole, all the numbers don't have a factor in common other than just 1. When I look at the variables, they do not all have at least 1 variable in common. Therefore, there is no GCF. So I move forward. The next question is, how many terms does the polynomial have? In our case, it has 4 terms, which means we're going to use the grouping method. The grouping method goes like this. I'm going to go ahead and rewrite the problem. 6ab minus 21a plus 4b minus 14. The first step in the grouping method is to draw a line between the first 2 terms and the last 2 terms. The next step is to simply draw a division line here and a division line here. Then you're going to ask yourself, what does the first 2 terms have in common? Meaning, what is the GCF between the first 2 terms? In this case, the GCF is 3, which we already said they both divisible by 3, and they both have the letter A in common, 1. Then you're going to write your GCF in the front. Let me write that a little bit lower. You're going to write your GCF in the front. You're going to open parentheses. And then you're going to write what is left. Meaning, once you divide each term by the GCF, for the first 2, what is left? Well, 6 divided by 3 is 2. The A's are canceled, so you're left with 1B. Negative 21 divided by 3 is negative 7. The A's are canceled. So that was the first step. We did the first part. Now you're going to do the same with the second one. What does these 2 terms, the last 2 terms, have in common? They are both divisible by the number 2. So the GCF for both 4b and negative 14 is 2. You're going to bring this sign. It's a plus 2, open parentheses. 4b divided by 2 is 2b. Negative 14 divided by 2, negative 7. Very important, very important. When you get to this step, this binomial and this binomial must match. If this binomial and this binomial are not the same, then there's a problem. You must go back and check your work because a mistake was made. Since both binomials are the same, we're going to go ahead and rewrite it. We're going to say 2b minus 7. They're both the same, so you're going to factor 1 out. leaving you with 3a plus 2. I'm going to put that here. 3a plus 2. Close parentheses. Need to move my face. It's in the middle. All right. Oh, let's put it a little bit higher. Right there. And that is it. All right. So I'm going to put a note here. This and this must be the same, right? Okay, let's see another example. Okay, so we're going to start the same way. We're going to go ahead and draw our line. Actually, we need to ask for a GCF. If you look closely, there's not a GCF between the 4 terms. So we're going to go ahead and draw our line in the middle. Draw line here, line here, line here, line here. What does the first 2 terms have in common? They both have an x squared. You can factor out an x squared. Then that x squared goes right here. You open parentheses. X cubed divided by x squared. So you have 3 x's, take away 2. You're left with 1. Right here, you're left with just 3. This is negative. You notice this part? This little, let's use a different color. No, let's use a different color. Some more color that we have not used before. Purple. See, since this is negative, you're going to go ahead and take out a negative. Oops, I'm writing in the wrong place. I'm going to divide by a negative. So they're both in common, negative 3. All right, so then the negative comes here. And you're left with x. Negative 9 divided by negative 3 gives you positive 3. You notice that this binomial and this binomial are the same. So yes, which means you're going to take 1 out. And the leftovers is x squared minus 3. And that's it for the grouping method. All right, let's see more examples. So we're going to start the same way. We ask ourselves, is there a GCF? There's no GCF, so we're going to go ahead and divide in the middle. What does these first 2 terms have in common? They both have an a squared in common. So we're going to go ahead and write it here, a squared. Open parentheses, what is left? A minus 4. What does these 2 have in common? A negative 3. Notice the negative 3. So that comes out. We're left with a minus 4. Again, see how this and this are the same. So you bring it down. And you're left with a squared minus 3. Very similar to the previous example. All right. Must match. The a minus 4 and the a minus 4 must be the same. If they're not the same, a mistake was made. Okay, we go to the next example. I do believe there is a GCF here. We have the number 2, a, 6, and 24. If I'm not mistaken, they are all divisible by 2. Right? Do they all have at least one a in common? Yes. They all have at least one a in common. So this right here is first step, GCF. So I'm going to go ahead and put my GCF here in the front. I'm going to go ahead and open my parentheses. What do I have left? A cubed minus 4a squared minus 3 plus 12. Now, the remainder polynomial It's a polynomial of 4 terms. Oh, I forgot an A here. Oop, there. Of 4 terms. So I'm going to go ahead, split it down the middle. What does the first 2 terms have in common? An A squared. What do these two have in common? A -3. So then I'm going to, don't forget this guy. Let me go ahead and draw a line so I know I'm not going to forget it. So I have A squared, open parentheses. Left, I have A minus 4. Here I have a -3, open parentheses. I have A minus 4. So I need to finish, right? They're both the same. The binomials are the same, which means I can bring that down. A minus 4. Left over, A squared minus 3. I don't like that 3. Minus 3. And my GCF must come down because it is part of the answer. With examples like this, the number one thing that the number one part where the students struggle is that they forget to bring down the GCF. Don't forget the GCF. Write it there. Don't forget the GCF in your answer. Don't forget it. Because if you forget the GCF, if you were to multiply this, you will not get back to the original answer. And if you don't have the GCF, that will be wrong. All right? So in this example here, we need to look for the GCF as well. Excuse me. And I do believe we also have a GCF here. First step, GCF. So if I'm not mistaken, they all have in common. Actually, there's no GCF, right? Because of the number 3. Ignore. Let's go back. Tum, 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 tum. So yes, 4 divides by 2. Yes, 6 divides by 2. Yes, 8 divides by 2. No, 3 does not divide by 2. There's an X here, there's an X here, but not in this 2. So no GCF. All right. So let's go ahead and get started with splitting in the middle. What do these two have in common? They are both have a 2. And here they both have a -1. Don't seem like it's going very far. But let's continue. When you take out the 2, you're left with 2x plus 3pa. And then here, when you take out the 1, you're left with ap plus 3px. Well, that doesn't match, right? It does not match. So what happened? Maybe we can go ahead and say, you know what? As we can see, the order in which the problem is given is not working. Maybe we need to reorganize this. Maybe we can say, you know what? I'm going to put the 4x with the -8, and I'm going to put the 6p with a -3. Maybe, let's see. So this order didn't work. Let's organize it again. So I'm going to say, I'm going to put the 4x with the -8. Is that what I said? Let's try that. 4x with a -8. 8. And then I'm going to put these two together. Let's see. Plus 6pa minus 3px. Let's see. So I decided to reorganize it. because the way it is not working. Now, I don't know if this one is going to work, so I have to try it, all right? So I have a 4 on both, and here I have a, what, 3p, right? So then I have a 4, so I have a, oops, I was going to put 2. I have an x minus 2a. Then I do plus 3b, and here I'm going to have a 2a minus x. Yeah, it's not working, right? Well, miss, but they're like the same. This is an x minus 2a. This is an a minus x. I mean, a 2a minus x. It should work because, I mean, they're basically the same. But are they the same? If you notice, the x is positive. The x is negative. That's not the same. So we're close. It's just our signs are not the same. Maybe we can put this first and then this one and see what happens. You gonna want to try that? Let's try that. Let's go ahead and try that. So we said we're gonna go ahead. Oh, I need to erase that too. We said we're gonna go ahead and say, you know what? Negative 3px plus 6pa. Let's try that. Hopefully that's it. I think I have negative 3p. Negative 3p. So here I have 4x minus negative 2a. Here I'm going to the negative 3p. And then I have x minus 2a. Finally, third attempt, right? Third attempt. Then we notice that the binomials are the same. Notice the process. If they're not the same, even by the sign, we have to make sure we go back, fix our work, because they have to be the same. All right? So then we take out the one that's repeated, we write it, and that's what we have. Now, some student might say, well, can I write this first? Can I say 4 minus 3p and then the x minus 2a? Of course, it's the same. It's the exact same because it's multiplication. Once you multiply, you're going to get the same answer. All right? So this is the notes for factoring by grouping for section 4.5 part 2. All right?